12 no ma. My internet connection is unstable ma. 1 second, wait, I'll change the layout, okay? So that it's recently poor, huh? How come? Okay, I'll change the layout. Yeah, listen, Prachita. Class 12 students have opened a separate group, so they keep me updated of what they are doing. Okay. If you people are doing the same, please add me too. Okay, fine, Prachita. Because I have got the
Yes, ma'am,
procedure
definitely.
this Saturday. They are going to start their project in the lab. Okay, because I have made the chemicals and everything ready. They are going to determine the presence of metals in chocolate. That's their topic. So I've kept the reagents, only sample they'll be bringing. I've kept all the reagents ready. For you people, you need sodium carbonate to check the foaming capacity of soap. So what is the progress? Whether you have selected, whether the procedure you want from me, in what way I can help you, you have to tell me. Otherwise, I'll not be able to help you, right? So Prachita, then who else is there in your team? You are there, Varish is there. Then,
Yes, ma'am.
ma, Jermia. Okay, okay, Jermia is there. Okay, okay. So today I have to get some updates from three of you. Okay, fine. Now moving to thermodynamics. That is the page. Yes. Yeah. So we have already seen about thermodynamics, but I'll do a quick sum up here. So system is a part of universe where observations are carried out. The remaining part, the rest part of the system is called as surrounding. So under the types of system, we have seen about open system, closed system and isolated system. Open system, where both matter and energy can be exchanged with the surrounding. So reactant in an open test tube is an example for open system. Closed system can exchange energy, but it cannot exchange matter with the surrounding. Example, reactants in a closed vessel. Isolated system where no exchange of energy nor matter takes place with the surrounding. Example is reactant in the thermos flask. And the thermodynamic process is classified into 7 types. What are they? Isothermal process. In isothermal, so temperature should be kept constant. There is no change in temperature. So delta T is equal to 0. If you plot a graph with V and PV graph, so you will be seeing exponential graph where delta T is equal to 0. So if I try to solve the equation
Voice
PV is
loss.
equal to nRT, voice is lagging pa. Girish?
No, I said Boyle's laws graph.
Okay, okay, you're saying about, okay, okay, sorry, I heard it like voice lag. Okay, since delta T is equal to 0, PV is equal to nRT, so PV is equal to constant, so P is inversely proportional to 1 by V. So PV graph, which is nothing but your Boyle's law. Generally, we remember Boyle's law like this. PV, right? When price is more, volume is less. Imagine there are two shops, right? Where one shop the price is more, in the other shop price is less. Obviously, where the people's volume, where the crowd will be, where pressure is less, where price is less, their volume will be more. The people's crowd will be more when price is less. The same way you have to remember your Boyle's law. Pressure is inversely proportional to volume. When pressure is high, volume is less. When volume is more, pressure is less. So under isothermal process, change in temperature is 0. So you'll be getting a PV graph. P is inversely proportional to V. Second one is, I'm going to isobaric. Last, I'll come back to adiabatic. Isobaric process. Bar is a term used to refer pressure. So here pressure is maintained constant. Here you will be getting VT graph where V is directly proportional to temperature. Now imagine you're having a system. The system is filled with gas. You have a piston attached system here. So when you heat this cylinder which is filled with gas, what happens? Volume increases because gas expands. So V is directly proportional to T. When you heat it, obviously volume becomes more, so the piston moves up. So this is all about isobaric process. Next, what is isochoric process? Where volume is kept constant. Change in volume is equal to 0. So here the graph will be P1 V T1 is equal to P2 V T2, where volume is remaining constant. Finish. Next one is cyclic process. In cyclic process, change in internal energy is equal to 0. What is internal energy? Internal energy is sum of all energy possessed by a system. It includes translational energy, rotational energy, potential energy, kinetic energy, etc. You can determine only delta U, but internal energy cannot be determined directly. But change in internal energy can be determined. In cyclic process, change in internal energy is equal to 0. Fine. Then coming back to adiabatic process. In adiabatic process, heat transfer is 0. Q is 0, that is delta Q is equal to 0. Transfer of heat will not take place, so delta Q is equal to 0. Now, moving to reversible process. The process which proceeds infinitely slow by a series of steps. In all the steps, equilibrium will be maintained. This is called as reversible process. What is irreversible process? The process which proceeds rapidly. The system does not have a chance to achieve equilibrium. This is called as irreversible process. So what is reversible process? It has to proceed slowly because in each step you need to maintain equilibrium. Irreversible process, there is no need to achieve equilibrium. Here the process will be proceeding rapidly. Now, till now, is it clear to everyone? For isothermal, delta T is equal to 0. If delta T is 0, then delta U is equal to 0. What is Q? Q is equal to minus W. Once again, wait.
Ma'am, why is delta U equal to 0 if delta T is 0?
If change in temperature is 0, then wait a minute. Yeah, once again. Yeah, I'm able to write now. What happened?
And because temperature change will happen only when there's a change in kinetic energy. So therefore, you can say that if delta T is 0, then delta kinetic energy is 0. Ma'am, but it need not mean delta potential energy is 0, right? So therefore, since total energy includes even potential energy, the potential energy could have increased or decreased while the temperature remains constant. So what about such a case?
See, when the temperature change is 0, then if you say kinetic energy is 0, then potential energy need not be 0, you mean to say. But what is the change in internal energy? It includes all, right? It includes potential energy, it includes kinetic energy. Say, for example, I am saying potential energy plus kinetic energy. If potential energy is 0, then kinetic energy will also become 0. Delta U will become 0. If change in temperature is 0, then change in internal energy is 0. Say, for example, the equation for internal energy,
Ma'am, I'm
change in
asking how
internal energy
temperature
is
is
equal
related
to,
to internal energy.
you need to check with extensive and intensive property. Wait, I'll come one by one. See, what is delta U is equal to? Delta U is equal to Q plus W. This I have explained while explaining state function and path function, right? Q and W are what? Whether they are state or path.
Ma'am, they are path.
They are path function. Why? Because they're dependent on the path followed by the system. So I'm saying delta U is equal to Q plus W. If delta U is equal to 0, then Q is equal to minus W. Now we need to see about the sign convention. I'll come one by one. Q is equal to minus W. Wait, for an isothermal process, delta T 0, delta U 0, delta U is equal to Q plus W. So Q is equal to minus W. For isobaric, delta P is 0. For isochoric process, delta V is 0. Volume change in volume is 0. W will be 0. Work done will be 0. So delta U is equal to Q, which is nothing but your first law of thermodynamics. Delta Q is equal to Q, which is nothing but your first law of thermodynamics. So first law of thermodynamics is what? Energy can neither be created nor be destroyed but can be transformed from one form to another form. In case of isochoric process, where change in volume is zero, work done is zero, so delta U is equal to K. In case of adiabatic process, heat transfer is zero, Q is 0. So what is delta U is equal to? Delta U is equal to W. Delta U is equal to W. I have merely supplied this equation and I have just used this equation to get all these remaining terms. So this is all about the types of thermodynamic process. I need to go in detail with the reversible process and the irreversible process. Reversible process proceeds infinitely because under each step equilibrium should be maintained. Under irreversible process, it should proceed rapidly. There is no need to achieve equilibrium. Now, for reversible process, external pressure need not be constant. For a reversible process, external pressure need not be constant. What happens to irreversible process? What happens to irreversible process? In case of irreversible process, external pressure will be constant. You understood these 2 points. So this will be helpful for me to explain the final equation. So reversible process proceeds infinitely slowly because in each step equilibrium to be maintained. In reversible process, my external pressure will not be constant. P external is not constant. This is not constant. For irreversible process which proceeds rapidly, so each step equilibrium to be maintained, here P external is constant. What is extensive property and what is intensive property? The property which depend upon the mass, quantity, or size of matter present in a system is called as extensive property. For example, mass, volume, internal energy, enthalpy, heat capacity, work, etc. What are these? These are extensive property, means the variables which depend on the mass of a system is called as extensive property. The property which depend upon the quantity or the size of the matter present in a system is called as extensive property. Say for example, mass, volume, internal energy, enthalpy, heat capacity, work, etc. So just say the opposite. Intensive properties means the variable which do not depend upon the mass or quantity or the size of matter is called as intensive property. For example, temperature, density, pressure, viscosity, refractive index, mu, boiling point, melting point. These does not depend on the mass of the system. So these are called as intensive property. So what is intensive property? The properties or the variables which do not depend on the mass of a system is called as intensive property. What is state function? State function is a teacher. It is independent of the path. It depends only on the initial and the final state of a system. Example, pressure, volume, temperature, enthalpy, entropy, free energy, etc. What is internal energy? The sum of all energy possessed by a system is called as internal energy. So first law of thermodynamics states that energy of an isolated system is constant. Energy of an isolated system is a constant. Now imagine I have a system which is nothing but a cylinder which is filled with a gas. It is with a piston. Now I am trying to apply heat to that system. Now I have a system. This system is filled with gas and here I have a piston. I'm going to apply heat to this system. What I'm doing, I'm applying heat to the system. We are still in first law only, right? What is first law? The energy of an isolated system is a constant. So when I apply heat, this there is a change in the internal energy of a system. There is a change in the internal energy. When I apply heat, then the molecules gain kinetic energy, then they start moving faster, they vibrate faster. So there is a change in the internal energy. And the piston moves upwards because your gas is expanding, the piston is moving up. So there are two things happening. The heat energy applied to the system will change the internal energy, as well as the piston has moved up. So there is a change in the internal energy. So the heat which I applied to the system, what it has done, it has changed the internal energy. Also the piston has moved up. So work is also done. So Q is equal to U plus W. Delta U, change in internal energy. So delta U plus W. What is Q is equal to delta U plus delta U plus W. This is Q. If I take delta U out, then it will be Q plus W. Why W has taken a positive charge here? Because work is done by the system. Why delta U? Because initial, this is delta U is equal to U final minus U initial. What is U? U is internal energy. Final energy minus initial energy is delta U plus W. So first law of thermodynamics states that energy of an isolated system is a constant. The heat energy supplied to the system is used to bring a change in internal energy. Also the work is done by the system. So the sign convention here is positive. So when I say W positive, then work is done on the system. W is negative, then work is done by the system. When Q is positive, then heat energy is absorbed by the system. Q is negative, then heat is evolved by the system. Anything which we are doing, then that is minus. Anything which others are doing for us, then that is plus. You are getting free, right? Because others are doing for us, so it is free, so it is positive. When you are doing by your own, you are spending your own energy, so it is minus. I'm repeating again. When work is positive, when work is done on the system. When work is negative, when work is done by the system. When Q is positive, heat absorbed by the system. When Q is negative, heat is evolved by the system. So, during compression and expansion, what is happening? Let us see. See, during expansion, what happens? V2 is more than V1. That is, final volume is more than the initial volume. So, delta V is positive. Delta V is positive. In that case, work done will be negative. In that case, work done will be negative. I'm repeating, work of expansion and work of compression. I'm explaining now first expansion. So what is expansion? During expansion, the final volume is more than the initial volume. So Vf minus Vi. So delta V will be taking a positive value because initially you have some volume, and after applying heat, say for example, the volume has rise. So obviously the final volume will be more. So when you subtract final volume from initial volume, your delta V value will be positive. But work is done by the system. So W is negative. This is in case of expansion. Now, in terms of compression, what happens? During compression, you are compressing the piston. So, initial volume will be more than the final volume. So, in case of compression, my delta V will be negative. Work is done on the system. So, W is positive. I'm repeating, during expansion, see the piston has moved up from the initial volume to final volume. So final volume is more than initial volume. That's the reason why delta V is positive and work done is negative. During compression, the
And
piston
you
it has
wrote,
pushed, it's
like in
being
the
pushed
textbook, it is written
downwards
delta U equals
in
Q
this.
plus W, but you wrote Q equals delta U.
Where, ma?
You wrote delta.
Internal energy.
You wrote delta U equals Q plus W, but I mean
Uh,
you wrote Q equals delta U plus W, and the text says delta U
uh.
equals Q plus W.
Both the see here, see the second equation. I just told this point so that you can understand easily. When I supply heat to the system, there is a change in the internal energy because the kinetic energy will increase. They absorb heat. The molecules will take up heat energy, so kinetic energy is more. In that case, there will be a change in internal energy. So the heat supplied to the system will be of two way. One way it will change the internal energy. In other way, the piston will be moving upwards, so work is done. So the heat which I supplied to the system has brought two things here. One, it has brought change in internal energy. The other one, work is done here. So, but the first law of thermodynamics states that energy of system is constant. Energy of an isolated system is constant. So they have brought this delta U. Delta U is equal to Q plus W. I have shown this equation and I have written to understand the rule. I have written to understand. Now, I was explaining about expansion and compression. During expansion, my piston is moving upward, final volume is more. Obviously, when I subtract final volume from initial volume, my delta V will be positive, so work done will be negative. During compression, the piston is moving down. In this case, my initial volume is more than final volume. So obviously, when I subtract final from initial, I'll be getting a negative value. So delta V will be negative and work will be positive. This is your work of expansion and compression. Children, till here you understood? Prachita, you understood, ma? Till here?
Yes, ma'am.
Whether I'm there. Vidyut, you understood. Merrick, you understood. Merrick, whether you understood, pa? Merrick is there only, right? Yeah. Merrick, you understood.
Yes, ma'am, I'm here. Yes.
You understood, right? Okay. Moving further. So I think I explained about the heat conventions, right? Yeah, I explained about the heat convention. Then coming back to this reversible, I told you I want to explain some more, but till now you people wait a minute. I told you to remember two aspects under reversible and irreversible. Yes. Reversible process, under reversible process, my external pressure is varying. It won't be constant. So this is reversible process. So you will be getting an exponential graph here. You will be getting an exponential graph here. Under irreversible process, my P external, that is external pressure will be constant. Here I will be getting a rectangular graph. Here I'll be getting a rectangular graph. Now I have few questions. Now I'm saying work is done by the system. What is the value of W? Make it fast. Work is done by the system. Then what is the sign for W? Whether I'm there. Hmm. Work is done by the system. Tell me what value, I mean, what sign my W will take.
Negative.
Fast, pa. Yes, ma?
Negative.
Work is done by the system, I said. So you have said W is equal to negative. Fine, here expansion. Done. Now, I'm asking the second question. Work is done on the system. What sign my W will take? Work is done on the system. Then what sign my W will take?
Positive.
Positive, correct. Heat is given to the system. What value my Q will take? Fast. Heat is given to the system. I have given free. I have given freely. So what is the value of Q here? Given to the system. Given to the system, heat energy given to the system. So what is Q value, whether it is positive or negative? When anything given freely, it is positive. When you are going to release, anything coming in is positive, anything going out is negative. Heat energy given to the system, then Q is positive. Heat energy released by the system, then Q is negative. Q is negative. Okay. Now I said for an irreversible process, my external pressure is constant. So you'll be getting a rectangular graph. For a reversible process, my external pressure is varying. So I will be getting an exponential graph. So till now we have understood what is system, what is surrounding, the types of thermodynamic process under that isothermal, adiabatic, isobaric, choric, cyclic, reversible, irreversible. Under reversible, you have to remember two more points. For reversible process, external pressure is not equal to constant. So here I will be getting an exponential here graph. Under irreversible process, my external pressure will be constant. I will be getting a rectangular graph. Then I have learned, then we have seen about extensive property. Extensive property depend upon the variable which depend upon the mass of the system is extensive. Variable which will not depend on the mass of the system is intensive property. State function, the variable which depend on the initial and final state of a system, they are independent of the path. Path function, they are dependent on the path. Under path function, you have heat and work done. Then what is first law of thermodynamics? Energy of isolated system is constant. Now I have a cylinder which is filled with gas, piston loaded. I'm supplying heat to it. So that heat will bring about a change in internal energy and work will be done. So from this, I have got the first equation as delta U is equal to Q plus W. Okay, this is what your doubt. Girish, you asked minus sign here, delta U minus W.
Yes, ma'am.
Was that your question? Because here, why minus W? Because it is done by the system. Work is done by the system. The piston has moved upwards. It is done by the system. So
No,
here,
ma'am. Like
okay. Uh-uh.
for first equation itself, when you rearrange, you'll get delta U minus Q equals W. So
Mm.
there's some inconsistency in the two equations I said.
Q is equal to delta U minus W. Then in that case, you'll be getting the correct equation. I supplied heat. So this heat has brought about change in internal energy. Got it? And work is done by the system because piston has moved up. Work is done by it. So it is minus W. So Q is equal to delta U minus W. So delta U is equal to W. So delta U is equal to Q plus W. Correct, Nopa?
Yes, ma'am.
Now you got it here. There should be one. This is what I think your confusion. Yeah, I have made a mistake here. Sorry. So if I supply heat, this heat will bring about change in internal energy. So delta U, and also work is done by the system because the piston has moved upwards. So it is minus W. In that case, delta U is equal to W. So delta U is equal to Q plus W. Okay, done. Wait, so you understood when I'm supplying heat, then in that case, Q will be positive. If heat is released by the system, in that case, Q will be negative. Then work done by the system, then W is negative. Work done on the system, then W will be positive. Okay, here. Then what else? Okay, I think I'll stop here. In the second thing, I want to write few things. So I will switch to, I'll try to log in by means of phone so that I want to write few points. Okay. Okay, children, thank you. We will join by, what is the time? Correct time, right? 10:20, 20:26. Okay, fine. So who is absent in the second session?